Yeah, so good evening and welcome on the DataOps Poland meetup. So today, the Edgaras from Vinted about how they managed to deploy thousands of the pods in Kubernetes using the GitOps. So Edgaras, you are a star. I'm stop sharing the screen. So please check if you are able to share your screen. Yep.
All right. So,
We
hi
see.
everyone. Thanks for having me. Really happy to be here. And as Tomasz mentioned, my name is Edgaras. I work as a SRE at Vinted. I'm working previously I was working in compute and CI/CD team that was responsible for the Kubernetes and all of the CI/CD pipeline, but just recently our team has been split into two parts. So I stayed at the compute part. So at the moment I'm working with pure compute Kubernetes stuff, but I think that I'm still eligible for to tell you about the GitOps and how we actually mastered it in Vinted. First of all, probably most of you know that Vinted is a second-hand fashion marketplace. I think it's pretty popular in Poland, so don't need to tell more about it from that perspective. But talking about the winter infrastructure, I want you to get a brief overview of at what scale we're actually using the GitOps. So first of all, the screenshot on the right, on the left-hand side, there's actually a tweet from our CTO like 1 year ago, and he said that we do have more than 140K requests per second during the peak time. So that's actually minus all of the image traffic that's being taken care of our external CDN providers. So mostly those requests actually interacting with our core application, and meaning that, again, most of these requests are interacting with databases as well. So in DataOps, there's going to be talk about our scalable MySQL database called Vitess. And yeah, so going back to our infrastructure. So at Vinted, mostly all of the services running at the moment on Kubernetes. I'm saying mostly because all of the stateless applications are running there, and all of the database stuff actually are running on separately on bare metal. So in Kubernetes, we're like keeping only clean stateless apps. And on the right-hand side, you can see a screenshot from our casual Monday deployments stats. So we do have around 2,000 deployments per day using GitOps. And our two main Kubernetes clusters actually running around 20,000 pods. And those pods are running on 700 physical nodes. So that's around 80,000 cores of CPU and around 300 terabytes of memory. So yeah, you saw it right. We're running on physical nodes, and we're not using cloud for our compute. The main reason for that is because at that kind of scale, it's more cheaper to run on our premises and co-located data centers.
Okay, stop. If you can stop, we have two questions. Okay, at the beginning, what platform do you use to run on-prem Kubernetes?
Yeah, so actually we're using vanilla Kubernetes open source version, and we're doing integrations and all sorts around the Kubernetes by ourselves.
Okay.
If that answered the question.
Yeah, I think yes. So how many Kubernetes clusters? I think it was, you said two, but correct me.
Two main clusters, but in production we have like 4 clusters, 2 infrastructure clusters, several sandbox clusters. But yeah, mainly we have 2 Kubernetes clusters.
Okay, and the last one, how many Kubernetes deployments? How many services?
Yeah, right. So can't see the top of my head exact numbers, but I believe around 6,000 deployments and around 4,000 services probably deployed, cloud or hybrid hosted. It's a cloud.
Okay, I'm sorry, I'm smiling because it's just the second slide, and I'm not sure if I'm able to read all these questions. So maybe let's skip. Let's wait until we skip this slide, and the next one I will ask the questions. Okay.
Right. Sure. Okay. So yeah. So let's talk about GitOps. What it is? It's kind of a center of our stage, right? So right. So we know the Kubernetes, the most popular container orchestrator down there. The Kubernetes actually simplifies how we deal with the infrastructure and application, how we scale everything, orchestrate, and so on. But actually, where Kubernetes falls short is and has frequent challenges is like managing application deployments, right? So in 2017, WeWork CEO actually coined this term GitOps when they released their software as a service solution called Flux. And with Flux, they actually tackled the deployment to ease deployments to Kubernetes. So since then, this terminology and methodology has been picked up by the cloud native and Kubernetes community, and this GitOps, let's say, movement actually got boosted popularity. And yeah, so if we're talking about GitOps, so GitOps is actually a DevOps process that's being DevOps process that provides best practices for the deployments, management, and monitoring containerized applications. It's actually a developer-centric experience for managing applications with full automated pipelines, workflows using Git for the development and operations, and the use of Git revision control system to track and approve changes to infrastructure, right? So yeah, so why GitOps? Well, GitOps actually provides many benefits to developers because it allows them to treat the configuration of infrastructure and deployments as a code in much the same way like they're managing the infrastructure and their software development process. So with infrastructure as a code, developers can codify the changes and store the manifest of the infrastructure as a code in some kind of revision control system. So infrastructure as a code provides us repeatability, meaning that it's easier to repeat same process over and over and over again multiple times, and much easier to do rollbacks than just tinkering with command line interface, running manual commands, and so on. Also, with infrastructure as a code, we get a reliability, meaning that our automate processes actually reduce the chance of human error. We get the efficiency, and with visibility, actually the code itself documents how the infrastructure should look like. So another key point for why GitOps, why should we use GitOps is with GitOps, we can have self-service, or how it's trendy to say now, internal developer platform. There's a tool like open source Backstage. And with self-service, instead of for the developers to send IT tickets to DevOps and so on, they can actually work on the code by themselves and create pull requests with their changes. And with code reviews, besides error prevention, let's say when you have two peer reviews, you can also teach and share knowledge during those code reviews, right? So jumping a bit to Kubernetes, in Kubernetes world, there's two ways how you run your applications on Kubernetes, right? There's imperative way and there's declarative way. This imperative way, you run your application just with a single command line, with single command, but there's a problem. You don't know who ran that application, why that person ran that application, and when it actually ran that application. With what kind of configurations and so on. With declarative configuration, you have everything stored in your YAML manifests. And if you store that declarative configuration manifest in your code revision systems, you can also get the history of changes, get information who did changes and when these changes were made. So combining Kubernetes declarative configuration manifests with Git, you get quite a GitOps way of implementing changes. So as you can see, this is a standard DevOps workflow of CI and CD, right? So when you build and you deploy your application, so GitOps actually has this recommendation when you keep your code in your separate repository and the Kubernetes deployment manifests in a different repository from the code. And it's actually even a good practice to have a Kubernetes deployment manifests in a single monorepo. So if you go through this CI/CD pipeline, so when we build our code and if we combine this pipeline with Salsa software security chain framework, we can build our code. Then CI tooling pickups our code, runs some tests, scans the code, builds the code, pushes to the Docker registry, signs the container itself, checks the container signatures, runs on the registry some kind of scans again, then clones the Kubernetes manifests monorepo and updates needed files with updated container image tag and pushes that to the master branch. Then the CD part takes over, clones, when changes were made, clones the Kubernetes configuration monorepo, discovers with which manifests has been changed and applies them to Kubernetes cluster. So with monorepo of our Kubernetes manifest, we can also have code owners. We have centralized some kind of linting tools, and we have two peer reviews. So everything that's being made with application deployment is centralized. Right. But when we do have a monorepo, we have to some kind of manage multiple environments. Environments can be multiple Kubernetes clusters or production development environments. So there are two main strategies how we can deal with environments. So one strategy which is not recommended is to use long-running branches. Those are kind of complex to manage if you want to promote your applications between environments. And the recommended way is to have separate directories. For example, you have your monorepo, you have your application, and that application can have child directories of its environments. So in that way, it's quite easy to promote your application between environments. You just need to copy paste your Kubernetes manifest between the directories, right? But if there's a quite big scale, you can copying pasting files can be a bit messy. So there's actually some tools for environment promotion. In this slide, you can see there are two open source tools. One is Telefonistka, which actually checks for the changes for your application between environments and automatically creates pull requests based on your configuration. and just recently launched open source tool called Cargo. It's by the developers of Argo CD, if anyone knows it. And what's nice with Cargo, you can also have a nice looking UI. Okay, so there are tools for managing the configuration of your Kubernetes deployment manifest. The three main tools are Helm, Customize, and JSONnet. Helm is actually more of a package manager, not a configuration management tool. It has the Go templating language, so anyone who worked with the Helm charts know already how painy can be the Go templating language with all of those if and else statements, nested ones, and so on. And with Helm, you can actually define environments per value files. So Helm is actually the most popular one between those three. Then there's Customize. Customize is a tool that as close as you can get to Kubernetes manifests, but it's quite hard to implement if you have any kind of edge cases. And with Customize, you have overlays per environment. And the third tool is with which you can manage your Kubernetes deployment manifests is JSONnet, which is actually more a language than a tool. It's actually a JSON with commands and templating. Not only Kubernetes specific, meaning that you can also write Grafana dashboards with JSONnet. But out of those three, JSONnet is actually least favorite because nobody actually likes JSONs. Okay, so talking about Vinted, Vinted had mainly, let's say, three ways of doing the code deployments. So before Kubernetes, we had Capistrano. Then when we launched our Kubernetes platform, we switched to GitOps, and nowadays we're using GitOps with Canary deployments. Yeah, so before Kubernetes, we were using Capistrano, and I have to mention that Vinted is actually a Ruby monolith core application. So before Kubernetes, we were running this core application on bare metal nodes. So Capistrano, what it did, it actually took a list from console service discovery and took a percentage of those hosts and deployed code down there. And as you can imagine, it was quite difficult to manage those deployments. We had some issues. So yeah, so that's when we actually wanted to have a Kubernetes platform, and we thought of using GitOps for the application deployments. So a brief overview of our GitOps architecture is for GitOps continuous deployment stuff. We're using Argo CD. And with Argo CD, we're utilizing this feature app of apps, which means that it actually scans our Kubernetes monorepo and looks for application YAML files. And from that application YAML files, it knows that this application needs to be deployed in certain environment. Then it gets which values files of the Helm charts this application is using. And from that application YAML, Argo CD knows which Helm chart that application is using. And combining all of those, Argo CD deploys applications to Kubernetes cluster. From the other end, for the CI stuff, we have Jenkins that actually applies image tag to our Kubernetes deployments monorepo. So that's a brief overview of our GitOps architecture. Now let's drill down a bit more. So this is how they actually, yeah, you're gonna see now a few YAMLs. Don't be mad at me, please. So this is actually quite a few how apps pattern work. So this is how the application YAML file looks like. And as you can see, we're using our custom plugin named app template. So it's actually a bash script that goes through the monorepo and finds all of the application YAML files. Yeah. And this is an example of our Kubernetes monorepo deployment, how it looks like. So we have some kind of applications, and those applications can have, let's say, environment values and environment applications. So Argo CD knows to which environment this application should be deployed and which values file should be picked up. Also, if that application is being deployed to several environments and some of the, let's say, configuration needs to be reused, we can also use a common values YAML file. So as you can see, here is our application YAML, and in application YAML, we are actually defining which Helm chart to use, which Helm chart version that application is using, and which value files that application is using. So in Vinted, we're using our own written centralized Helm charts. So you can see we have pretty much every use cases. We have cron jobs, daemon sets, deployments, jobs, stateful sets. So probably the question would be why we're using centralized Helm charts, and are we using any external Helm charts? So there are edge cases, but when we're using our own written Helm charts, we can do decentralization of labels and annotations. So we have some kind of standards for labels and annotations. And also, it's easier for us to implement integrations such as with HashiCorp Vault Secret Management, right? So, yeah, so this is how our Helm chart directory looks like. And every Helm chart, our base Helm chart has values YAML file where you can see the whole configuration that's possible for developers, and we have also the minimal example value file, which is enough for developers to run their simple application. Yeah, so to show you that, let's say, in a picture, on the left-hand side, you can see how many values, variations you can have, your application can have and utilize, like probes, init containers, sidecar containers, and so on. And on the right-hand side, you can see just the minimal stuff that's needed for your application to run. So our Helm charts are quite, let's say, flexible, right? And when you have your values file, this is the view from the Argo CD. It's Argo CD application view, and you can see how your application is running. I got to say that for our core applications, we do run several thousand pods, and if you open our core application view, sometimes your browser gets stuck because a lot of pods are being shown here. Right, so how do the image tag changes are being rolled out to deployments repository? Well, every code repository has its own Jenkins file, but again, we're providing centralized Jenkins jobs like Docker image build and publish and Kubernetes deployment supply. So Docker image build and publish under the hood builds the Docker image, scans it, signs it, and publishes to our internal container repository. And Kubernetes deployment supply, what it does, it actually updates the values file image tag. Okay, so this is how the Jenkins works. Right. So as I mentioned before, Vinted is a Ruby monolith, and for someone who doesn't know, when you're deploying code for Ruby, you also have to do database schema migrations before rolling out new code. So luckily, Argo CD has sync waves. So in our Helm charts, you can provide some kind of job, let's say the IB migration, and you can say that sync wave is -1, means that this job is being run first of all. When this job succeeds, then the main code is being rolled out. And a little tip for anyone who has frequent deployments. So on the right-hand side, you can see example how Vinted core application frequent deployment is. It's around 10 to 20 minutes every new revision is being deployed to production. And when the core is being deployed, there's also another job from Argo CD that actually calls another application rollout. And before that, we had an issue when core rollout is in progress, and Argo CD calls another application sync, that another application sometimes gets a different code revision. So when you're using Argo CD app sync, there's a nice flag called revision, and you can provide the same provision that your code is being deployed. So we have GitOps. GitOps is mostly roll forward. So how do we deal with rollbacks? So at Vinted, we have developed a chatbot that actually with which when we need to do a rollback due to, let's say, some kind of bug in the code, we can call chatbot to log our Argo CD application synchronization. Then we can apply our last known image tag revision that we know it is without a bug. And after the bug is fixed in the streamline, we can unlock the application and start the Argo CD's auto sync. So yeah, but we wanted to actually automate rollbacks in case something goes wrong. So we actually started doing canary deployments with analysis. So for that, we chose another tool from the Argo family called Argo Rollouts. So Argo Rollouts does blue-green deployments, does canary deployments, and you can do analysis based on Prometheus metrics, on Datadog, and so on. So in this case, what we're doing is actually every hour release scales to 40%, does the analysis run on the Prometheus HTTP request metrics, and checks for the error rate. If everything's all right, we then run to 60%. Again, analysis is being run. If everything's okay, then we fully run code on the new revision. And yes, this has worked a few times now, and a few incidents were obeyed. Yeah. Okay, so yeah, so I was quick. So if anyone's interested, I can talk about scaling Argo CD for the high load. So in short, Argo CD has a couple of components. So Argo CD API server that's actually does the visualization, UI stuff. Then there's Argo CD application controllers that actually apply changes to Kubernetes clusters, and Argo CD repo server that retrieves manifests from the Git server. So if we have too many applications, like in our case at Vinted, we have around, let's say, 600 applications per Argo server. We can increase number of processes. So the default is actually pretty low, 20 processes, but we can, at the moment, we have it increased to 200. But keep in mind that if you increase the processes, you also have to increase the resource CPU limits and requests. And if you have a bit more clusters and a lot of applications in them, you can always shard the application controllers, meaning that you just need to increase number of replicas of application controllers. Then there's a repository server. So typically running 3 or 4 of those servers is enough. You can always control the parallelism, meaning that if you do have a lot of, let's say, resource usages, you can lower the parallelism, but your repository cloning will take a bit more time. And with the provided annotation, you can cache the repository. And that's actually my last slide. So in summary, GitOps is awesome, while GitHub works. If it's not, you can always go home. But in short, GitOps lets you to do fully self-service, to track changes easily. Also, good tip is to use directories for the GitOps environments in your deployments, Kubernetes deployments monorepo, and separate code and configuration repositories. And if you have some kind of repetitive configurations, you can just use common values to not have same values in all of those files. So yeah, that's it on today's topic.
Yep, thank you. So before the Q&A session, let me check the questions on the chat. So cloud or hybrid hosted? So I think you already answered that. You use the virtual server, right?
Yeah.
Yep, and probably as usually, the issue is cost of the clouds. I mean, cloud providers, right? So at the scale that you are using, that maybe I'm talking from my experience. Usually, not the cost of the instance is so high, but the transfer of the data, it's killing you pretty shortly.
That's right.